In this video, we are going to understand the problem called a sum of subsets, which we are going to solve it by using a technique called backtracking. So, for solving this, we are going to take an example, which is a very small example, so that we can understand it very easily. We have only 4 elements here. If you can observe here, we are having only 4 elements. So, we have 3, 4, 5, 2, we call. And then we are going to, so we'll say that we have n elements. So we have 2 elements here, sorry, 4 n elements, n is equal to 4. And then we are going to have the sum value, which we are going to indicate that sum value is equal to 9. So what we need to do in this problem is, first of all, we are going to identify a set of elements whose value will be equal to 9. So if you take this example here, where we are going to have the elements of 3, 4, 5, 2. So we say 3 plus 4 is 7, 7 plus 2 will be equal to 9. And 4 plus 5 is also going to become 9. Because now we are able to see them, or we are able to identify them very easily, because we are having only few elements. Now, if assume that we are going to have n numbers, where that n number is a big number. So when you find big numbers, or more than more than 100 elements, and so we can't identify them. We can't identify those elements where we can find the sum. Okay, so for this technique, for what we do is that we are going to implement the algorithm called as backtracking. We know that backtracking is a concept where we are going to find more than one solution. And whenever I say that we are implementing backtracking, means that we are going to apply your DFS, which stands for depth first search, where we are going to perform the task which is there to the left side of the tree, and then we are going to evaluate the right side of the tree. And we call this type of technique, I call it as my DFS algorithm. So now we start this algorithm, we'll understand this one. We'll see how we are going to solve it. So for doing it, what we are going to do is, we are going to add the values. Suppose I say, so in the beginning, we are going to take 0 elements as understood, and we are going to sum all those elements. We are going to sum all those elements, and if you are going to sum all those elements, that value will be equal to 14. So now we are going to choose the first element. So whenever I say that we are going to choose one element, I say, so we are going to indicate all these elements as, I choose this element as x1, I call this element as x2, I call this element as x3, and I call this element as x4. So now I call this element. Now we are going to choose element number 1 is equal to 1. If I say 1, means that we are going to choose that element, and instead of 1, if I say 0, it means that we are not going to choose that element. Now, if I choose the first element, means, so whatever the value which is there as the first element is added to this, and whatever the value which is added to 0 is subtracted from here. So what we are going to get, we are going to say 3, and then if we are going to substitute this 3 from the 14, we are going to have the value 1. As I said, that whenever we are going to implement the concept of my backtracking, we are going to implement DFS, means we are going to evaluate the left side first, and then we go for the right side. So now we are going to see whether this value is equal to 9 or not. So now here this value is not equal to this number, so we are going to go forward. So now what I do now, I'll choose my second element. And if I choose my second element, what is going to happen? This 4 we are going to add with my 3. So if I add my 4 with my 3, it is going to become 7. And whatever the value which is added here, it has to be subtracted from this value. So this is also going to become 7. Now we are going to check whether this value is equal to 9 or not. Now this value is not equal to 9. So again, what we are going to do now, we are going to choose my third element. We are going to choose my third element. And if I choose my third element, see here now, if I choose your third element, now what is going to happen now? Oh, so this value, so if I choose that value, this is going to become 12 and this is going to become 2. Now we are going to compare this value with this value. Now we see that this value is bigger than this number. So whenever I find the value which is bigger than this m value, then we'll say, then what we are going to do is we are not going to go forward, or we'll say that we are going to kill this value, or we are going to kill this node. So for killing this node, what we are going to do is, for killing the node, we are going to have a bounding function. So now in this case, the bounding function, now the bounding function is, what you say, it should be the bounding function is that it is should be less than or equal to 9. So we are not going to satisfy that condition here now, because we are not going to satisfy. So we are going to kill this node, and after killing this node, now what I do is I move forward, because we are not going to have the solution from this side, so what I do is I move backward. So when I move backward, means that when I say x is equal to 1, we say we are going to choose this element. Now I'll say, now at this point, now I'll say x3 is equal to 0. Now if you say x3 is equal to 0, it means that we are not going to choose my x3. So what is the value of my x3? The value of my x3 is equal to 5. So because if we are not going to choose that value x3, so now the values which we are going to have here is, we are going to this one will be 7, and from the whole sum we are not going to assume that x3. So whenever you are not going to assume that x3, so this sum value will be equal to 2. Now what is happening now? No, because we are having that 5 value, right? So we are having x3 is equal to 5 there. So whenever I say this is not been taken, is not been considered, so what we are going to do, that value we are going to substitute from, we are going to subtract from the 7. And if I subtract the 5 from 7, this is going to become 2. Okay. Now, if you are not going to choose my x3, so what is the value which is left here? The value which is left here is equal to x4. Now, I'll choose my x4, where the value of my x4, if you can see the problem there, the value of my x4 is equal to 2. So, we are going to add that value to. What we are going to do now? We are going to add that value 2. And if you are going to add that value 2 to this 7, it is going to become 9. Okay, and now what we are going to do here, we are going to subtract that value 2 from this number. So now what we are going to get now, so this number now, whatever the value which is expected by us, right? So whatever the value which is expected by us is been reached at this point. So I say this one will become your solution. So now how we are going to represent this solution? This solution is represented in this way, because I say we are going to have 4 elements. Okay, so what we are going to do, we are going to draw 4 boxes. What we'll do now, we are going to draw 4 boxes, and x1, x2, x3, x4. So we are going to include first element, we are going to include your second element, we are not going to include my third element, and we are going to include your fourth element. So the solution will be 1101, will be one solution. As I said earlier, whenever I talk about the backtracking, whenever we are going to have multiple solutions, we are going to say we are going to apply the concept of backtracking. So now there is a possibility of having multiple solutions here. Now we'll see what are the other solutions we have. So now we got one solution here. Now we'll see whether we have another solution or not. If and we are not, and we are going to see if you are going to have a solution if I don't choose your first element. So now in this case, now at this point of time, we started with choosing your first element. Now what we are going to do? Now we are going to say x1 is equal to 0. X1 is equal to 0 in the sense we are not going to we are not going to consider my first element. And if you are not going to consider the first element, so we are going to start with 0. And if you are going to add this value, what are the values? What is the sum of those numbers? That number will be equal to 9. So now we started with x1 is equal to 0. Now, if we are not going to consider my x1 now, we can consider my x2. Now, what I do here now, I'll write here like x2 is equal to 1. It means now we are going to consider my x2. And if I consider my x2, the value of my x2 is equal to 4. So what we are going to do, we are going to add the 4 to my 0. And if I add my 4 to that 0, so what we need to do now, we need to substitute this value from this 9. So now this one is going to become, 1 second, this should not be equal to 9, no, this is 11. So what I need to do, I need to, this is 11. So now what did this now if I substitute, if I subtract from 4 from this number, what will be the value we are going to have? We are going to have the value called as 7. Okay. Now after choosing my second element, now we can even choose my third element because this number is not satisfying that 9. So what we are going to do now? Now we are going to choose my third element. So if I choose my third element, so what is my third element there? According to my problem, the value of my third element is equal to 5. So we are going to add this 5 with this 4. So this is going to become 9. And we are going to subtract that 5 from the 7. This is equal to 2. Now again, we are able to find the solution here. Okay, now we are able to find the solution here. Now the another solution which we got for this sum of subsets is 0. What is the subset we are going to get here? This is 0, because you are not going to choose your first element. I am choosing my second element, I am choosing my third element, and also we are going to choose your, and we are not going to consider your fourth element. So it is one of the solution. Again, as I said, whenever I talk about my backtracking, we are going to have multiple solutions. So now in this case also, what I am doing now, we are going to have multiple solutions here. Solution number 1 and solution number 2. So now whenever I compare, means we said that whenever I want to kill the node, we are going to have a bonding function. Now we'll see what exactly the bonding function is, which we are going to use in this problem. So the bonding function here is the summation of, this is I equal to 1 to n wi xi plus w k plus 1 is less than or equal to m. So what is this Wi? Wi are the weights. So these are the weights now. So W1, W2, W3, W4. So Wi, this is called as my Xi. If you are going to consider it, we are going to treat it as a 1. If you are not going to consider it, it is going to be treated as 0. So this condition or this equation now, I call this equation as your bounding function. So we can also have another examples. Okay. So now we have seen an example earlier. So now we are going to have the code, and we are going to understand how simple the code is if you like to write the code in the language of C for your sum of subsets. So for doing all those things, for what we do is we are going to assume the array, as we said that we are going to have an array. So we are going to have the array, right? So we are going to have the array. Okay. So, 1 second. Yeah. So we are going to have the array, and the elements are, and the array elements are like 3, 4, 5, 2, as we said in your example. So now what we are going to do now, with the help of these elements, now we are going to calculate what is the size of that array. So what I can do now, just we are going to have the simple operation. By the simple operation, we are going to understand what is the size of that array. And then we are going to have a function here called sum of subsets, where this function is going to take 5 arguments, right? So the first argument will be the array. So now we can see what is the array now. And the second argument is going to explain you, or it is going to give you how many elements are there in your array. And the third, your third argument is going to say, is going to talk about what you say, this is called as the sum, right? What, because we are going to find the sum, right? So we are going to add the values one with another. So we are going to have this value which is to be sent. We are going to have the index also. So this argument is very interesting. I will be talking about your what you say, third and fourth argument later, but for now we need to understand these 3 arguments first. So this will be the array, this will be the size of the array, and this one will be the index from where we are going to start your start your adding of numbers. So now if you go forward right now, so in this program, what we are going to do is, as we all know that your C program should include this header file. So without including this header file, we cannot have your input output statements as a part of your code. And then now what I do is, now we are going to declare a global array. And this global array is meant for creating a sub array where the sum of that subarray is equal to your sum. So the total sum is equal to 9. As I said, while understanding the problem, the total sum, that value of my m should be equal to 9. So that value 9 we are going to store in my target sum. And then we'll see what is the total number of nodes also. So how many number of nodes we are going to consider. So these elements are the basic variables which we need to have as a part of the code. Now we are going to understand the code now. So we are going to call the method called sum of subsets, and it is going to take that array. It is going to take the size of that array. And then now, as I said, this one is going to specify the size of the temporary array which we are going to create. Because whenever I add some values, right? And the sum of that value should not exceed that m value. So we need to create a separate array where the sum of those elements of that separate array should not exceed that 9. So we are going to create, or we need to understand what should be the size of the temporary array size. Okay, this is. And then we need to understand the fourth argument. As I said, it is being treated as a sum. As I said, whenever I choose some elements from my subset, that sum should be less than or equal to 9. And at the end, this index value, which is a very interesting argument which we are going to pass. Suppose if I start my array from 0, right? So the next time we should not start from 0. We need to start from 1. And then we need to go for 3. And then at the end, we are going to go for 4. It means that this index value is going to erase, what you say, duplicate value. Suppose I say, suppose if I take an example, like if I have 5 and 3, and we have a set called 3 and 5. So this index value is going to erase these duplicate values from your subset. So for erasing the duplicate values from your subset, where there is a possibility of falling into what you say, infinite recursive calls. So we are going to use this index. Now we'll see what is going to happen now. Now, if the sum, so we will say that we are going to add the values. Okay, so we are going to add the values of my array. Okay, so if that value is equal to your target sum, so if this is been satisfied, it means now if you are going to satisfy your bounding function, if you are going to satisfy your bounding function, if you are going to satisfy your bounding function, then we need to print the elements which are there in that subarray. So these statements are going to satisfy. It means when your sum or the sum of the elements which are there in that array is equal to this 9, then we are going to execute this block. And if it is not satisfied, right? So if it is not satisfied, we'll see what is going to happen now. So what I do now, just we are going to run one iterative loop, I index. So what is that index now? As I said, whenever I want to erase the duplicate elements from your array, we are going to say the index and I less than the size, right? So we are going to give my second argument as the size. Then we need to compare. We are going to execute your loop till that point. If my sum plus s of I is less than or equal to your target sum, then we are going to perform this operation. Okay, if this condition is satisfied, what you are going to do now? We are going to perform this operation. If uh, after sending these values into my temporary array, okay, now what this temporary array is going to do now? This temporary array is going to keep my elements which are being identified. And again, with these elements, again, we are going to call my sum of subsets again with the same value. So we said I plus 1 again. Again, we are going to change the index. So the index will be 0, the index will be 1, the index will be 2, and the index will be 3. So with this logic, right, now we can execute your program very easily without any errors. And why my interest of giving code for the students is that uh, we need to have a simple logic for solving your backtracking. So that's what my intention of giving the code and explaining the code so that it can be very simple to see. Okay. So I hope you understood the concept well, and also you understood the code, how we are going to convert the concept into the code.